Hydrolysis according to the Stanley Meyer model. Cell of Stanley Meyer. The shape of the electrolyzer Stanley Meyer. The form can be absolutely any. Meyer proceeded from the fact that an electrolyzer is a capacitor in which water is a dielectric. Therefore, Stanley Meyer made an electrolyzer in the form of a capacitor by calling her Meyer cell in his honor. The work of the Stanley Meyer cell consists of several stages. Stage of initial. We have a water molecule consisting of a negatively charged oxygen and two hydrogen atoms charged positively. There are capacitor gaskets on which 0 volts are currently supplied. The next stage is stage on the capacitor linings. 250 volts are served. On the anode plus it turns out plus 125 volts. On the cathode minus, it turns out minus 125 volts. And we see in the figure that the water molecule stretched, negatively charged, oxygen is attracted to the anode. Positively charged hydrogen is attracted to the cathode. Stage, we increase the voltage, put it 500 volts. At the same time, we will have plus 250 on the anode. Volt, there will be minus 250 volts on the cathode. And we see a water molecule stretch even more. Staged, increase voltage to 750 volts. And we see that on the anode we will have plus 375 volts. On the cathode we will have minus 375 volts. And we see that the water molecule stretched even more. Finally, the stage E is the stage of the molecule break. The molecule is torn under the action of voltage per 1000 volt, and we see that the oxygen atom, negatively charged, is attracted to the anode, and hydrogen atoms, positive charged, attracted to a negative cathode. Stage of when the voltage is removed. We see that the voltage on the capacitor lining absent, and accordingly the atoms of oxygen and hydrogen in the form of a gas are released. Here in the figure we can see the model Meyer in dynamics. According to the schedule, you can see the stage A, stage B, stage G gap stage of when the voltage is removed. Traps in which the repeaters of the experience of Stanley Meyer fall. This voltage is greater. What is necessary for breaking the water molecule? Constant stress, that is, says lack of impulses and selection of frequency for the frequency of water molecules for resonance. We will analyze them in more detail. High voltage trap is when the voltage is more than it is necessary to break the molecule. That is, for example, if we see on the graph that we have the voltage of the rupture of the water molecule is 1000 volts, and we supply 1500 volts. Then where it goes, excess 500 volts. Excess voltage goes to heating water. That is, an electrolyzer in this mode works. As a boiler, this is not economical. A trap of constant tension, that is, the absence of impulses. When most of the atoms of hydrogen and oxygen settles on anode and cathode. Here the figure shows that we have an anode and a cathode under constant stress, and we see that most of the oxygen atoms settled on the anode, and most hydrogen atoms settles on the cathode, and only a smaller part is released in the form of a gas. Finally, a trap of resonant frequency. The frequency should be selected under the oscillatory circuit. The oscillatory circuit consists of a shutoff diode, two coils of inductance and capacitor. It is also a Meyer cell. We see in the figure that the scheme itself consists of an pulse generator, pulse reinforcement transformer, and oscillatory circuit. The whole secret is just that. Choose the frequency on the pulse generator that would coincide with the frequency of the oscillatory circuit. This leads to the fact that the voltage on the capacitor plates increases. And we see that here the scheme is just collected sequentially, which gives us resonance is an increase in voltage. If the scheme was collected in parallel, then there would be a resonance by current strength, and we need stress. That is no speech about the resonance frequency of the water molecule, or there are no atoms of hydrogen and oxygen here. About the reasons why it is selected precisely under the oscillatory circuit, I will tell in the next video.